In this video, we're given the graph of a polar rose curve, r of theta equals 3 cosine 5 theta, and we can see on the graph that this is a 5-petaled rose. When that coefficient of theta is odd, the number of petals equals that coefficient. And we're asked to use this curve to sketch the graph of a related curve, 3 sine 5 theta. So the idea is, instead of using brute force, we can think about a transformation of trig functions that allows us to get one curve from the other. So a quick reminder of a trig identity here. The sine of theta is cosine of theta minus pi over 2. In other words, if we advance a cosine function by pi over 2, we arrive at a sine function. So I'm going to apply this to my polar curve 3 sine 5 theta, and that should be equal to 3 cosine of 5 theta minus pi over 2. And then I'm curious, how much has the angle been advanced? Because I can think of that as a rotation of my original curve. So I'm going to factor out a 5, and I get theta minus pi over 10. So in other words, I replace theta with theta minus pi over 10 in this original graph, and it's going to produce my new graph. Well, what does it mean to replace theta with theta minus pi over 10? That means we advance in the positive direction for theta by an angle of pi over 10. In other words, it's a counterclockwise rotation by pi over 10. So those are the numbers that I plugged into my computer algebra system, and I built a little animation to illustrate what's going on here. And so we arrive at the graph of 3 sine 5 theta with a simple counterclockwise rotation. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.